Okay, I came back. And now, yes. Screen. No. Okay. So we are going over letter C together. So which is the 2i4. Really slow. Plus 3y cubed minus 16y squared plus 15y minus 4 equal to 0, right? Okay. So we are list all possible rational zeros. So what are the key value to determine possible zeros?
The real number and the first coefficient.
Yeah, so this one, and then these numbers, right?
Right.
Yeah.
Okay. Now, therefore, we are making negative 4 over 2 so far. And then we are finding their factors, multiply them, become those numbers. So for case, you can do 1 times 4, right? And 2 times 2, so I put only 1 time here, but as you know, they're going to be all plus and minus. Because when you multiply that, negative 1 times 4 or 1 times negative 4 become negative 4. Negative 2 times 2 or negative 2 times negative 2 also become negative 4. So that's why those are factors of 4. Now 2 case, plus and minus 1 and plus and minus 2. Yes? But as you know, plus or plus become plus, and then minus or minus become plus as well. Also, plus over negative become negative. So technically, you don't have to put plus and minus on denominator factor. So do you know what I'm talking about?
Yes.
One more time.
You only
here.
wrote 2 once because 2 times itself equals to 4.
Yeah. But what I'm saying is, even though we have plus and minus here, because we have this sign here, so plus over plus become plus. Minus over plus become minus. Plus over minus become minus. Minus over minus become plus. So it kind of a conflict. That's why you don't have
They
to
cancel each other out.
Yeah, plus and minus on denominator value here. Okay, then now we can make 1 over 1, 2 over 1, and then 4 over 1. There will be one possible zeros. And another branch here, 1 over 2, 2 over 2, 4 over 2. If I list them, then this becomes 1 plus and minus 1 over 1, plus and minus 2 over 1, plus and minus 4 over 1, and then plus and minus 1 over 2, and plus and minus 2 over 2, and then plus and minus 4 over 2, like this. So if you simplify, then we can list them like plus and minus 1, plus and minus 2, and plus and minus 4, and plus and minus 1 over 2, and then plus and minus 1, and plus and minus 2. So far, so good?
Yeah.
And as you see, these two repeating, so you don't need it. Sorry. So they're all our possible zeros. So that's the A answer.
What if we simplify?
Yeah, we simplify. That's the reason.
No, in the beginning, minus 4 divided by 2.
Oh.
It's gonna become minus 2
Yes.
divided by 2, and we have only 2.
Yeah, that's great questions. But as you see, we have 3 here, 15 here. They are not divisible by 2. So you want to divide by, you want to simplify, then you need to divide by 2 every factors. So as you see, 3 and 15, they are not divisible by 2. So we don't do that. Okay. So that's A answer. And instead division to find rational zeros. Okay, synthetic division, we are taking their coefficient and then constant numbers, right? So we can do 2, 3, negative 16, and 15,
Minus 4.
negative 4. So fourth power, third power, square
That's
power,
13,
single power.
not 15.
Yeah, that's good. So, I mean, yesterday I emphasized that even though we have only this number, we have to understand last number is constant. Second last x, and then middle become square, and third and fourth. We have to notice that. Now, among these rational and possible zeros,
Did you freeze?
you want to try?
Hello?
Yes.
Did he freeze out?
No,
Oh.
I can see you. I can see, hear your voice.
1 makes it 0.
So we have all possible zeros are here, and then it is up to you which one you choose. But easier is better. So let's just give us one possible zero.
1 makes it 0.
1.
Yeah.
Okay, let's try 1. Okay. Now, what's the first step? We do it.
Lower
You
down.
drop down
Bring
the
the 2
2,
down.
Drop down the first number, and then
Multiply.
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 yeah, become 2. Then what's next?
Add.
5.
5.
5
Professor,
5.
Multiply by 1.
minus 9.
Professor Lee.
Isn't negative 11?
Negative
Hello.
9.
Hello?
I think it's 13, not 15.
Oh, 13. Okay. No, it should be 15 actually.
It's 15.
Sorry, my handwriting sometimes looks weird.
15, yeah.
Sorry. So 15 from the page 114, letter C.
Yes, negative 11.
So negative 11. So negative 11 here, right?
That's 4.
4, and 4, 0. Okay, we found one rational zero here. Okay. Then now, I mean, if you want, we can do one more time. But since we have 4 terms, we can think about different factoring method. Can you think about the method we can utilize? Well, actually, this time you
Grouping.
may not be able to use it, so one more synthetic. Can you find another one, another possible zeros?
The 2.
2? Okay, let's try 2. Then we drop down 2 here. The 4, yes?
Yeah.
Yeah.
9 and 18
18.
and
7.
7. So it's not working. So
Right.
Professor,
should we try negative 2 maybe?
what if we plug in the value, the number that we suggest on the formula itself and like switch between the number with y. By that, maybe we can just find it faster. Isn't it possible or no?
Can you show your paper, your work?
No, I mean like we plug in the value, the possible zeros
Into where?
into the question itself, like 2y.
Oh, I see.
One with y.
So you mean we are plugging into here basically, right?
Exactly, but I mean without like ignoring
Yeah.
the power, ignore the power. So like 2 multiplied with 1 gonna be
Mhm.
2, 3 minus 16 plus
Mhm.
plus 15 negative 4.
Yeah.
It will be 0.
I see.
Like the question we did yesterday, instead of having the synthetic
Mhm.
formula, maybe we can just find the possible zeros and then just plug it in the question. Is it possible?
Okay, then I'm gonna just follow what Osama just did here. Then which value you wanna input here then?
It's gonna be only one. There is no other possible way.
You sure?
Of course.
We have only one possible zeros?
No,
which
no.
is
I mean, what
two.
we did already. The one which is worked, but
Yeah.
I didn't try another number.
Oh, I see.
But
Okay,
if you
anyway, when I see this one, it is not factorable either.
Mhm.
Well, let's try maybe 7 more value, and then if not, then I also go to your method soon. Okay, Osama? So let's try synthetic one more time. So which value do you think it may be possible? Maybe 1,
2.
2? No, we tried 2 already and it didn't work.
try -2,
-2?
baby.
Okay, let's try -2. Then 2 come down here.
Right.
So -4 then, right?
1.
1, negative. So it's not working because it become -13.
Yeah.
Then it's way bigger. So it's not working either.
What about half?
1/2. Oh, that's good option. Let's try. Okay. So you mean positive 1/2 or negative 1/2? Positive?
I have a question.
Maybe
Yeah.
Why didn't the 2 work? Like, how do you know that 2 didn't work?
We just look at the so let's see again. So 2, then 2 comes down, and then 4, right?
Yeah.
9 and 18, and this is 7, right?
Yeah.
So 2 times 7 becomes 14. So we want to aim to find this equal to 0, but it is
All
actually
right.
18, so it's not working. That's how we confirmed.
All right.
Now we want to try 1/2. Is it 1/2 or negative 1/2?
I think so. Negative 1/2.
Okay, negative 1/2. Okay. So then 2 comes down here, and then the negative 1, then 4,
Negative.
Negative 2.
2, then negative 13 again. So it's not working.
Not work.
Then let's try just the 1/2. What happened? So 2, 1, right?
Yeah.
6, 3.
Mhm.
Oh,
Negative
I think it's
8.
working. -8
Negative
and
8.
-4. Oh, it's working. Okay, so we found it. So far now we only have 3 terms left here. So I don't want to use a synthetic anymore. Instead, we can write so far x -1 and x -1/2 and 2x squared plus 6x minus 8. Yes?
Why is the x minus 1 there?
Oh, because
From the beginning?
possible ways.
Yeah, the reason is synthetic case, this value represent an answer for each divisor, right? So we are making x equal to 1. And then we switch this to factoring form, then you are substituting 1. So x
X equals -1.
equal to 0. That's the reason we are making x -1. And this will become x -1/2. Now, do you see a common factor here? Common factor?
2.
2.
2x.
So we can rewrite this 2x squared plus 3x minus 4, right?
Yeah.
So I'm gonna multiply 2 into this fraction, this parenthesis, then this becomes x -1 times 2x minus 1. And now factoring this one, then I'm sure I'm gonna skip the step, but anyway, so x plus 4 and x minus 1.
How did you do that?
I mean, the trinomial factoring. So from x squared plus 3x minus 4, the finding two number become -4, but their sum become 3. Oh, I think I made a mistake. No? No, yes. So we can do 4 times -1, which is plus 3, right? That's the reason I got that.
Oh,
So this is the order of factors anyway.
Professor,
Yes.
can you go back to when you tried the half?
Yeah.
Yeah, when you tried the half, did you try it on the
First one,
yeah, and the and what do you call it? And the on the number like beside the beside the y, the coefficient.
Oh yeah, you're right. So sorry. Everything must be y. Sorry. Because I sometimes not looking at the problem, so I switch the variable. Thanks for correcting this mistake. So everything must be y. Then, okay. So I think we did everything here. So list all possible zeros is right here. So that's the A answer. And
you scroll back down.
excuse me?
You scroll back down.
Yeah, scroll back down. Yeah.
Is this lecture will be recorded or no, Professor?
I think it's supposed to be recorded automatically, and then I try to post on the Blackboard.
Thank you.
Yeah. So that's the letter C. Okay, then now number 4. So can we move up number 4? Do you have any questions so far?
So what we conclude with it's the remaining solutions.
So remaining solution will be, okay, so that's great point again. So you can say y equal to 1, we found it. Also y equal to 1/2, and y equal to -4. And then this one gives 1 again, so I don't want to repeat because this is a square power answer. 1, 1/2, and -4. That will be the answer.
okay.
Okay. Any questions, anybody?
Why do you say that?
So Santiago, do you have any questions?
Yeah, how do you get
Alondra,
Yes.
any question?
No.
Okay. So then I think we can move on. Number 4. Okay. So number 4 here. So find a polynomial function with a real coefficient that has the given zeros. So A, we have -2 and I here, right?
Mm-hmm.
Okay, so, you know, when we have the answer before like this, x equal to 1, we are making factoring form, so this become x minus 1 from here, right? Therefore, based on the concept, you can rewrite this as x plus 2 and x minus I so far. So far, so good?
Do you always have to switch the sign?
Yeah, basically we are putting their opposite.
Okay.
Okay, then now here, please expand this to binomial, then what happened here? So let's do together. So x times x becomes
X squared
x squared
minus
minus ix
plus 2x
plus 2x
minus
minus 2I here, right?
right.
So we have a trouble. You know, the polynomial, we cannot have imaginary term. Even though we can have imaginary answer, but when you explain everything, there shouldn't be I. So we need to get rid of I.
What did it say? Did it say x squared minus ix plus 2x minus 2i?
2x minus 2I so far, yes. Because we are making this one as a factoring form. So I found here x plus 2 and x minus I. After we expand it, we got this expression. Unfortunately, we have an I term there, so it's not possible. We need to get rid of I term. So I need your help. Please find out how can we get rid of I term from here.
Can we do Groben?
Excuse me?
Can we do Groben factoring?
How?
So like just combine the ix with 2I and take out I.
Yeah, then you will go back to here then. You know what I'm talking about?
You'll try to put an exponent on the I and make it turn to a -1 so you can use the math on it.
That's a great point, but we do something here and then we need to get rid of item here. Okay, then. So,
You can add ix to both sides.
no. Then we still have I because it becomes ix squared minus I squared x plus 2ix minus 2I squared. So we still have I. We need to get rid of I.
Do I
Don't we multiply by -1?
you can take the root square.
We cannot because if you do x minus I squared, then they also become item exist. So we shouldn't have item here.
Can we just multiply by -1?
-1 still have I here because if you multiply -1 here, then this becomes negative x squared plus
No, I
ix.
mean only the -2i. Like the I
no,
for the
because then
-1. No?
the value got changed, so you cannot do that.
But Professor, the
Yeah.
I is represent the square root for -1, isn't it?
Yeah, that's right.
Okay, so we can just square everything.
Square everything, then this is going to be much bigger. So here, let's go back to number 3, which we discussed yesterday. So I'm gonna go back here. So fx was x fourth plus 2x cubed minus x squared plus 4x minus 6. I think Marshall find out possible 0, and then we did it already yesterday. Even though I'm not saying anything, I hope you understand what I'm doing.
Right.
Okay, then what was the possible 0 yesterday lessons?
1.
1. Okay, then 1, 1, 3, 3, 2,
2.
2,
6.
6, 6, and 0 here.
Right.
And now, because we have 4 term here, we can use grouping. So x cubed plus 3x squared plus 2x plus 6 so far. And then we cut half. So what is the common factor here?
X squared.
So x squared, then x plus 3 plus 2x plus 3. So this becomes x squared plus 2 and x plus 3. So
And x
we have
minus 1.
existing answer x equal to 1. I'm going to put it down here first. Now from here, x equal 3 or -3, also another answer.
Mm-hmm.
Right.
Now, so when you do this one, what did we get?
Yeah, it's the plus
The
minus
imaginary number.
square root of minus 2.
Yeah, so x equal to plus and minus square root of negative 2. So this becomes,
It's like one of them is square root of 2. The other one, minus I square root of 2.
no, it should be both I because we have negative here. So plus
Yeah,
and
but
minus
I negative 2.
yeah,
I
the square root
root
of
2
2.
basically, right?
Yeah.
So now that, which means we have I root 2 and negative I root 2
Mm-hmm.
to make this binomial. Now, what do we call these two cases?
So
Huh?
look,
What do we call this case?
My imaginary number.
I know about I root 2 and then minus I root 2. What do we call them?
Remaining.
Plus or minus I root 2.
So they're basically opposite, right?
Yeah.
They're opposite. Or as a complex number, we are calling as a conjugate. We did it before. So now go back here. Now we have I. Then now automatically, which one we have to think about?
The conjugate, it's negative I.
Negative I, yes. So even though it didn't specify negative I as well, but when you rewrite this expression, we have to count its conjugate automatically.
Only for the imaginary numbers.
Yes, exactly. Say one more time, a little bit slowly. Say one more time.
Only for the imaginary numbers.
Yeah, only for the
Mm.
imaginary numbers or complex terms here. So
Yeah.
it becomes x plus 2 and then x minus I and x plus I. Yes? Okay, then you multiply out this first, become x plus 2 times x squared plus ix minus ix minus I squared. So these two canceled out. So it become x plus 2 times x squared plus 1. I hope you understand why I got this one from here.
Why we can like from the beginning, from over there, from x negative I and x positive I, it's what do you call it? It's the
The
difference
conjugate.
between. You got what I mean, Professor?
Yeah, I know. So you are talking about the binomial factoring, right?
Yeah, so like we can just, because it's positive and negative, we can just
Yeah.
right away we make it as x squared negative I squared.
Exactly. That was a possible way. So this become actually x squared minus I squared, and this become x squared plus 1.
Plus 1.
That's good. Okay. So that's
Can you
the answer for number 4A. So because you showed the polynomial, so I'm
Can
gonna
you
make
explain that again, please?
Excuse me?
Can you explain that again, please?
Okay, so here, sorry. So whenever we have a complex number or imaginary number like that, its conjugate or opposite become another factor automatically. Therefore, when we write, even though these two of them is given, you have to think negative I as well. Because one more, so just one example here, if we do B together, so we have 1 and then 5I, right? So Alondra, do
Yeah.
you see I here?
Yes.
then you should think the opposite or conjugate also another zero value, which is
Minus 5i.
negative 5i. Make sense?
Yes.
Yeah, so because we have 5i, so we automatically think minus 5i also another possible factor. And now we are making factoring form, which means taking the opposite and then put it into the x and something. So become fx equal to x minus 1, x minus 5i, the x plus 5i. So make sense?
Yes.
By the way, when I count you guys, we have only about 7 or 8 people. What about
I
other
don't think
people? Did they go to school?
some of them received the link.
Heidi
And I
tried to
told you,
get in.
I told you I
Really?
couldn't
Couldn't.
receive the link at first.
Oh, I see. Then
And
I
Babacar
better
texted
email
me
them one more time.
that he couldn't receive the link either.
Okay. Therefore, now expand it for me. Then what do you get? This one. So this become x minus 1. I gonna keep it. You simplify this to binomial, then becomes
X squared positive 5 or positive 25.
so minus 25 I squared, right?
Yeah, would be positive.
Alondra, you know how we got from here to here?
Yeah, you just multiply this two here.
Yes, yeah. And then we using factoring method here. So a squared minus b squared equal to a plus b, a minus b. Okay. Basically, we are taking shorter term here. So final answer become x minus 1 times x squared plus 25. That's the answer for this problem.
So if Professor,
Yeah,
here they asking for the coefficient.
yeah.
So this is the remaining solution, or is it the coefficient?
So that's the answer basically, because there's no common factor between x minus 1 and the x squared plus 25. So it should be just as is. Or you can expand it because it shows like that. So let's expand it, then becomes x cubed plus 25x minus x squared minus 25. Therefore, it shows that x cubed minus x squared plus 25x minus 25. That will be final. Okay.
Okay.
How did you go from minus 25? Oh, never mind. You come with.
Yeah, I switched their
What did you do?
location as organizing
Oh,
descending
you just
order.
organized it.
Yeah. Okay, so I'm gonna give you some time for you to try C, and then we can go over that together, and then after that we can move number 5. Okay, so take your time
Professor.
and then
Can we
try
do another?
number 4C.
Can we do another problem like C?
Letter C.
Yeah, no, like number C, the one we did before. Can we have an? Can you show us another problem and go through it together?
Oh, I see. Okay. Yeah, we can do that. Actually, number 5 very similar to letter C. So we
Okay.
can do it.
Okay.
Professor,
Yes.
are other students able to join late?
Yeah, they can do it. Yes.
Yeah, because Heidi texted me saying she couldn't join it because the class is already in session.
Oh, let me try to. Okay, 1 second. Stop sharing. So, you know what? Okay, so let's try to together again. So now we have possible, I mean the given zeros. Two and five
5 plus
plus
1.
I, right? Okay.
Yeah.
So do you see I again?
Yeah.
Yeah, what would be another zero factor?
5 minus I.
Negative 5 plus I.
5 minus I.
Yeah, 5 minus I. Okay. So remember that you always switch item value
Okay, so
here. So
minus.
before we have only I, we also switch minus I, 5I, like opposite. Same thing, we have 5 plus I, so become 5 minus I. Okay, then now, this question will be a little bit different compared to others because it is already binomial form. So anyway, we can put gx equal to x minus 2 times x minus 5 plus I, then x minus 5 minus I. Okay, you understand why I put minus sign here? You see I set up or minus, minus, minus here.
Because you subtracted it from the x, so it could equal the negative. No, I mean it has like x minus 1, so you put plus 1, then x equals 1, like that.
Yeah, that's one idea. And then, like yesterday, we in the classroom we just talk about that. You know, we prefer writing positive answer.
Yeah.
Then you know that in the factoring form, x minus something represent positive answer. So we aim to put minus sign here. But if you want, in these two cases, you can put plus as well. But then you may get confused for your future class. So always make some habit to minus sign when you set up the factoring form. Okay, then let's expand it. So I will expand these two terms first. Then it becomes x minus 5 minus I, x minus 5 plus I. Wow, it will be long. Okay. Or, okay, let's keep on it. So this time this becomes x squared minus 5x plus ix and minus 5x plus 25 and minus 5I and minus ix and plus 5I minus I squared. Okay, then we can cancel out these two and these two. Yes? So I think I cancel all the possible opposite terms. Now you simplify, then x squared minus 10x
Plus 26.
plus 26, because this is the plus 1. So plus 1, 25 become 26. And then this, and we bring this down here, so x minus 2. So I wanted to say that's the answer, but since the question asked using the coefficient form, so we explain one more time. So x cubed minus 10x squared plus 26x minus 2x squared plus 20x minus 52. Okay, simplify, then x cubed minus 12x squared,
plus 46x
yeah, plus 46x
minus
minus
52.
52. That will be our function. Okay. All right, the same situation. I'm gonna give you a few more minutes. Think about number 5. So number 5 basically the similar to number letter C, but a little bit simpler. Because it gave you one of the zero value already. So try that, and then after a few minutes, we start going over the equation together. Good.
Yes.
So the given polynomial fx equal to 3x cubed plus 14x squared minus 23x plus 6 here. Okay, so we want to find out, so A, list all possible rational zeros. Okay, so Alondra, you asked me the question. So how to set up all possible zeros?
Wait. You have to divide 6 divided by 3.
Yeah, we set up 6 over 3
3.
because they are leading coefficient and then constant number. So 6 over 3, that's good. Now find out the factors. You multiply become 6 and
1,
then multiply become 3. So
1 and
becomes
6, and 2 and 3.
1 times 6, right?
Yeah. And 2
2
times 3.
3. And don't forget plus and minus.
Yeah.
What about denominator value?
1 times 3.
Yeah, 1 times 3. But as I told you, because we already put plus and minus on numerator factor,
You have to
so
put on
it
denominator.
is not necessary, right? Even though we have to, but that's not necessary anyway. So I'm gonna just delete plus and minus on denominator factor. And then now we kind of combine all this, then we can find the possible zeros. Like this. So if I list them, they become plus and minus 1 over 1, and plus and minus 2 over 1, and plus and minus 3 over 1, and plus and minus 6 over 1, and then plus and minus 1 over 3, and plus and minus 2 over 3, and plus and minus 3 over 3, and plus and minus 6 over 3. Now simplify, then you will get plus and minus 1, plus and minus 2, plus and minus 3, and 6, 1/3, 2/3, 1 and 2 again. But they are repeating value here, so we don't need that. Okay, the same as these two values, so I can delete them. So this is the all possible zeros. So can we move on letter B?
Yeah.
Okay, sorry, let's do letter B here. Use synthetic division to show that 1/3 is the zero of the given function. Okay, so we are doing synthetic. So don't forget we are taking all their coefficient and constant number. So 3, 14, negative 23, and 6. And then we are doing 1/3 here. Okay, so we draw down 3. So 1/3 times 3 becomes
1.
so become 1 because of 14 plus 1 become 15, and 1/3 times 15
5.
5. So negative 23 plus 5, I guess
18, negative
negative
18.
18, and then become negative 6 and 0. So that's the procedure we show them. 1/3 is basically one of the zeros. Make sense?
Uh-huh.
And now we want to find out the rest of the zeros. So far we have x equal 1/3. Okay, then now we can also do 3x squared plus 15x minus 18, right? So do you have a common factor here?
3.
3. Then we can do common factor first, then x squared plus 5x
5
minus 6. Okay.
minus 6.
Please let me allow to skip the step. So which means you don't know what to do, then you need to practice factoring more. So this come out
X plus
x
5.
plus 6, x minus 1, basically. Therefore, we have x equal 1/3, x equal negative 6, x equal to 1. There will be factor, 0 factor.
Please scroll back up.
Make sense? So on the other word, now we can rewrite this one. So 3 times
What
this.
about number 3? The common factor.
Yeah, you should multiply.
Yeah, we will do it now. So we have it here. So far we have 3 times x minus 1/3, x plus 6, x minus 1. If you multiply them, then this becomes 3x minus 1. X plus 6 and x minus 1. So as you see, this number basically didn't do anything to find the 0 value. We
Yeah,
still have these 3 value anyway. Now we want to draw the graph, right? The graph here. So 1/3 is around here. Negative 6, 1, 2, 3, 4, 5, 6, right here. 1 is right here. And now this is the odd functions, right? Then I see original is x cubed. Okay. And now all the factors have a single degree here. So I know that it starts from here and then here. So I can make like this, like that. Make sense?
Mm-hmm.
Yeah. So that's the number 5 answer. And then I have seen this question on the final already twice or 3 times. So you should know what to do clearly, so that when you see these questions on the exam, you won't lose any point.
Which question? The one with the graph?
I don't know whether you have to draw the graph, but until here, I always see that on the final exam. So you
Can you scroll back up?
okay? And who knows, if this time all the exam will be given as take home, so we can ask you maybe through the graph as well, right? So we better match with some difficulty, when we give you as a take home anyway. So we may ask you a little bit more complicated problem. So you better be ready. Any questions so far?
I have a question. So what will happen now? How we gonna be taking tests and stuff like that?
Oh, that's a good question. So let me pause for a second because this comment I can let you know later, but so A first. So 72 x fifth y cubed over 27 x y seventh. Okay, so anyone share your idea how to simplify this rational expression?
You have the common factor 9.
9, okay. Then, so let me know so what to do. So 9, then
Multiply I remember that I did like x5 when divide by x, so it's like x squared. And then this one, like epsilon 3 divided by y7 is like 1 divided by, so basically it's going to be 8x4 divided by 3y4.
okay, so what do you think? Is it correct answer or you have different answer or what you don't understand?
I
Because
don't understand.
You don't
y
understand.
y3
Okay.
divided by y7, it's equals to 1 divided by y4. And x5, you can simplify divide by x, so it's x squared.
So if I just summarize what Marshall just shared, basically he divided number first. So 72 and 27. What's the common factor? You can
9.
simplify.
8.
9?
Yes.
Okay, then 72 divided by 9 become 8.
Yeah.
27 divided by 9 become 3. That's what he did. And the next one is so x term here. So x fifth over x. So I mean,
X to the 4.
we know a to the m over a to the n equal to the m minus n.
And yeah,
Then you can see the 5 minus 1 become 4, right?
right.
The last one, y cubed over y7, which means y cubed
Minus
minus 7. So become y negative 4. That's why he put 1 over y4. That's
1.
what he did. But so from here, I think we can also go shortcut from here to here directly, basically. So compare which power, which exponent is greater. So obviously 7 is more than 3, right?
Right.
So count how many more and then put on the bottom here. So yeah, so Marshall did a great job. So 8x4 over 3y4 will be the answer for this problem. Okay, then now we know what to do. So also I haven't assigned, but let's also discuss b together. So b negative 6 w squared z8 over so 27 w and then z8. Okay, so basically it is similar to letter A, right? So number x, y before, then now we have number w and z. Okay. So Heidi, are you here?
Yeah.
Can you simplify number term, please?
-2.
We do
The greatest common factor is 3.
it's gonna be 2/7.
Yes, negative 2 over 7. That's good. Is it 7, by the way?
9.
9.
9. Yeah.
9. And then what about W? Which one is
W.
greater?
It would
So
be,
W2 is greater than W, right?
yeah,
How many greater?
1.
1.
So put 1 W on top here. Oh, yeah, same, so canceled out. So actually that's the answer. So negative 2 W over 9. So any question between A and B? No? Okay, then I can move C. C is 3y minus 12 over 2y squared minus 32. Okay. Can anyone share your opinion or idea?
Yeah.
What is it?
3 multiply open parenthesis y minus 4 all divide by 2 open parenthesis y square minus 16.
Okay,
So
and
y
then
square minus 16 is like y minus 4 plus y plus 4 in parentheses.
so we can make 3 minus 4, 3y minus 4 over 2y minus 4 times
Y plus
y
4.
plus 4. Okay, so let me pause for a second. So if you don't understand any step here, let us know so we can go over the question. So first of all, you understand from here to here?
Hello?
Yep.
I just joined the program. I don't know.
He was
So,
3.
yeah, because
the
of
greatest-
3y and 12. So as you see, 3 is common factor between 3 and 12, right?
Yeah.
Yeah. So
And then
Mamadou,
2
we
is a
are
common factor
doing
between. All right.
chapter 3, page 7, I guess.
Okay, thank you.
Chapter 3, page 7. Number 3C. That's what we are doing.
Okay, thank you.
So you understand here? So 3, 12. So 3 is common factor, so become y minus 4. And then the bottom part here, 2 and 32. So 2 is common factor. So after you factor in, then it's become y squared minus 16. Rondra, you understand? Okay. Now from here to here, did you get it?
Yeah.
Okay. Now, do you see any common factor between numerator and denominator?
Y minus 4.
Y minus 4.
So we can cancel this out. So our final answer becomes 3 over 2y plus 4.
When it had y squared, why did it go to y minus 4 and then y plus 4?
That's great questions here. So as you know, a squared minus b squared is what?
C squared.
C squared.
No, that's the Pythagorean theorem, which is a squared plus b squared equal to c squared. Now the factoring method here, so a squared minus b squared equal to what? So factoring.
Right, just a plus b multiply a minus b.
A plus b times a minus b.
Oh, yeah.
I emphasize this one you will use a lot, so you have to memorize it. You will prove that if you take calculus 2 or 3, but not this calculus. So please remember this property. You will use a lot. So now, y squared minus 16. 16 means what? 4 squares, right? That's the reason it becomes
minus
y
4 and plus
minus
4.
4, y plus 4. And then y minus 4, the common factor, you cancel them out. So left over 3 over 2 times y plus 4. That should be the answer. So make sense?
Mhm.
Okay. Then E is 2t plus 3 over
2t squared
t squared
plus
plus
7t plus
7t
6.
plus 6. Okay, then can I ask Mohammed, what should we do from the beginning?
There's no greatest common factor between 2 and 3.
Okay,
There's 1.
so we just leave it as 2t plus 3, okay. What about denominator?
2t plus 7t. Do you break apart the 2t squared?
How? So let me know.
7t plus 6. I don't know.
Yeah, just have Mohammed how to factoring this one.
To the table.
There's tables, right?
Yeah.
Okay, then moving this to here, then this become t squared plus 7t plus 12, and we have a equals 2. Yes?
Right.
Now to t chart 12 and 7.
4 and 3.
4 and 3. And we can make this one so far t plus 4 over 2, t plus 3 over 2, simplify then t plus 2, and then we cannot simplify, so moving this to here then 2t plus 3. Yes, Mohammed?
Yeah.
Yeah, okay, so we replace this one into denominator. So t plus 2 times 2t plus 3. Okay, now as you see, this and this canceled out. So answer becomes 1 over t plus 2. Okay, so I'm gonna give you a few more minutes again. So please do G and I, same page. So chapter 3, page 7. Number 3, G and I. Then we will go over the question together soon. Okay, so let's go over together. So the question was, so G is k squared plus 8k minus 9 over k squared minus 5k plus 4. Okay, Santiago, are you here? Santiago? Santiago, if you hear me, can you give me the factoring answer for numerator? Santiago?
The AK minus 9, it should be, I think, 4 and 3. 4 and 3.
I think you are doing opposite direction here. So whenever you have like this, right? Then you are finding two factor, you multiply -9, the sum becomes 8.
9 and -1.
It should be 9 and -1. Santiago, please practice. It always comes out. Yes? So it becomes
K
k
plus 9
plus
plus minus
9
1.
k minus 1. Okay. So the what's the denominator factor?
K plus 1, K minus 4.
Yes, k plus 1?
A minus 1.
Minus 1.
Minus 1. Minus
and
1.
K minus 4, right?
Mm-hmm.
Yeah.
So these two canceled out, so answer becomes k plus, what happened?
K plus 9 over K
K plus 9
minus 4.
over k minus 4. That will be the answer for this problem. So please be careful. You cannot cancel k and k here, even though it looks like you can cancel them because of their binomial or binomial. So those must have exactly same factor. Otherwise, you cannot cancel anymore. So answer is as is. K plus 9 over k minus 4. Okay, now I is 8b squared minus 6b minus 9 over ab squared minus 18b plus 9. So Christ, can you show your factoring answer? So Christ, we cannot hear you.
Sorry.
Hmm.
All right, so factor -9 times 8.
Yeah, so
Negative 78.
negative
72.
72,
Yeah,
and then
72.
Yeah.
negative 6,
Mm-hmm.
I
Minus
haven't
4.
done that one yet.
oh, okay.
Yeah.
So who can find two number? You multiply negative 12, but their sum become negative 6.
Minus 12 plus 6.
Yeah, negative 12 and plus 6. And then with a value, a equal to 8. Therefore, this becomes b minus 12 over 8,
And B plus 6.
6 over 8. Simplify.
So it's going to be AB minus 12
So b minus 3 over 2.
and AB plus 6.
I know, but
Oh,
we
wait. I need to
though.
simplify. Yeah. I forgot.
So b plus, I get 3 over 4. Okay, therefore, I can write this 2b minus 3, and then 4b plus 3. Okay, bottom one,
4B plus 6 and 4B plus 3.
minus 72, no, this time plus 72, and negative 18.
Minus 12 minus 6.
Okay, minus 12 minus 6. Okay, then it becomes, I guess, b minus 12 over 8 again, and then b minus 6 over 8. So 2b minus 3, and then 4b minus 3.
Right.
Yeah, so cancel same factor, which is this one. So answer becomes 4b plus 3 over 4b minus 3. That will be the final answer for this problem.
Could you go back to the work on the bottom?
Yeah. Okay, yeah. So I skipped a step here because kind of same as this one, but you keep on doing this, then you will get 3 over 2, and then 3 over 4 here, and moving denominator in front of variable. That's how I got 2b minus 3 and 4b minus 3 in this case. Okay, so now I'm gonna assign you a little bit more difficult one. So think about this problem. So 14 x squared y over 2xy cubed times 6x cubed y squared over 7xy 40, please.
Notice the greatest common factor is 7, so I divided it. So I just started like picking off like we did the first ones. The 14 and 2, like sectioned off variables. 14 over 2 became 7. The x squared over x became x.
Okay,
And
so I'm gonna follow you step by step. So 14 and 2, this becomes
7.
oh, what happened here? 7 oh why? 7 and 1, right?
Yeah.
And then
X squared and x became x.
this become x.
And then y to the third and y became y squared.
Okay, so y squared. So I can rewrite this 7x over y squared basically.
Yeah.
And then
I was doing the same thing for the other side.
okay,
But
then
the greatest common factor is 1, so you can't really do anything. So
yeah,
it's
so
6
6
or 7.
over 7.
And x cubed and x, so x squared at top.
X squared top.
And then
I
y
bottom.
y squared and y to the fourth, so just y squared at the bottom.
Now
You have 7x over 1y squared times 6x squared over 7y squared.
yes, so it becomes what?
6 6.
That's as far as that.
By the way, can we cancel 7 and 7 in this case?
Yeah.
Can we do like this?
Yes.
Yeah, we can. I think so.
Yes, we can because of one's numerator, the other one denominator, so it is possible. Then
Yes.
I think nothing else we can simplify. So answer becomes
Divide
6x cubed
6x cubed
over y.
over
Over y squared.
y fourth. Yes.
Yeah, I did it differently though.
How?
I just multiplied across and then simplified it.
Oh, okay then. So I'm gonna write here for you. So let me know what you did.
All right, so when you multiply across, you get 84x to the fifth, y to the third,
Y to the third over.
14x squared, y to the seventh.
Okay. And then you just simplify from here.
Yeah.
Okay, that's good idea too. Any other idea? Alondra, do you understand what is going on here? Alondra?
Yes.
Okay. Heidi,
Mhm.
I'm just checking because you guys are quiet. You get that?
Yeah.
Okay. All right, then maybe a little bit the same situation, but I'm gonna put two different binomials in this case. What about these problems? This. So 3 over x squared minus 2x times 2x minus 4 over x.
Do you just multiply straight across?
Okay, so let me know what you do. What did you do?
The 3 times 2, I got 6x minus 12.
Oh, so you are doing 6x minus 12 And then
X to the third minus 3x.
like this.
3x. Oh yeah, 2x squared.
Okay, then, okay, I think it makes sense too, but you know, like other questions, so let me go up here again. So like these questions, eventually we factoring each binomial and try to simplify, right?
Yeah.
So from here, even your case, it is not final answer yet. You need to simplify and then, I mean, you need to factor in first and simplify.
Yeah.
So what's the common factor between 6x and 12?
6.
6.
So common factor becomes
I think so. The
6.
answer would be 6 over x squared.
6. So factoring for 6x minus 12.
Yeah, the final answer would be 6 over 6x squared.
No, we don't want final answer yet. The middle step here.
So it will be 6 factorial x minus 2.
X minus 2. And then the bottom
Yeah.
becomes
X square,
x squared
x minus 2.
x minus 2. Okay, so cancel out, so become 6 over x squared here, right?
Yeah.
Okay, then now, without reaching this step, so can we go from here to here? Because sometimes on this step, so, you know, the blue step here, it can be very complicated. So even though that's great idea, sometimes it may be not a great idea.
Talk about my idea.
Even though, yeah, it is good idea though, but some case, this expression can be very complicated, then you may get stuck. So we will develop some idea, maybe from here to here, basically.
So you make it separately, you simplify separately, and then
Yeah,
you,
if possible, yes.
so x squared, x minus 2 and 2 on the other side, and then you yeah, I got it, yeah.
Okay, then that's good idea. So now 3 is just the one factor, so write 3 here. Then what's the common factor between x squared and 2x?
X.
X, then become x minus 2, right?
Mm-hmm.
And now, what about this case? What's the common factor between 2x and 4?
It's 2.
2.
Okay, then x minus 2 over
Yeah.
x.
X.
Now, do you see any common factor between numerator
2
part
minus
and
x minus
denominator?
2.
X
X
minus
minus
2.
2.
So we cancel this out. Now, anything else we can simplify.
We
Mhm.
multiply, yeah.
Yes.
No, we can.
We just multiply 3, 2,
Yeah,
and
Just
nothing
multiply.
else. So multiply, then 3 times 2, 6. X times x
Always
become
x
x
to the
squared.
square.
Yeah.
Okay, we reach the same answer, but we skip this step basically, right?
Mhm.
Yeah.
And Mohammed, so your idea is really good. I agree with this one, but just in case we are developing another way from here to here directly, because this step, your step can be complicated, then we may get stuck. That's the reason.
All right.
Okay.
Yeah.
But if you feel that's very convenient to you, then just do it. But just in case, I also let you know a little bit different way. Okay.
All right.
So what about this case now? So w squared plus 4w plus 4 over 2w minus 6 multiply w squared minus 9 over 5w plus 10. Wow, it's becoming much more complicated.
Yes.
Yeah, I also give you a couple minutes. So, and then we start going over together. So think about that, please. So who can tell me the first step?
So
Common factor.
first one is x plus 4, w plus 4 multiply w plus 1 in the first.
You
Divide by,
sure? Hold on. W plus 4 times W plus 1?
It's
Yeah.
W plus 2.
Yeah, W plus 2.
Yeah, I guess W plus 2 makes more sense to me. So W plus 2 times W plus 2, right?
Mm-hmm.
What about denominator?
2 parentheses W plus 3.
Plus 3?
Yeah.
minus 3.
Minus 3. Okay. Now, this one.
W plus 2, W plus 3.
W plus 2 and W plus 3?
No, W plus 3, W
minus
W minus 3.
W minus 3 factor W plus 3.
Okay. What about 5W plus 10?
5 parentheses W
Do-
plus 2.
Yes, good. Okay.
Yeah,
Then
you
do you
got it.
see a common factor between numerator portion and the denominator portion?
Yeah, cancel
Yes.
out.
W minus 3.
Or W minus 3?
Yeah.
W plus
Okay.
2.
W plus 2. W plus 2.
Okay. Anything else?
No.
Okay, no. Then we just simplify and answer becomes W plus 2, W plus 3 over
10.
10. Okay, I
I have
think
a
that's the
question.
final answer.
Hello?
Yeah.
I have a question. When you're simplifying, like for example, the W2 plus 4W plus 4, and you got W plus 2, W plus 2. How do you do that? Because you,
Basically, in this is trinomial factoring here, right? Trinomial.
yeah,
You're finding you multiply 2 factor become 4. The sum become 4 again. So 4
2 and 2.
you can
All
break
right.
them out 4 times 1 or 2 times 2, right?
All right. I get
Which
it.
sum gives you 4?
2 and 2.
Yeah, that's the reason we got W plus 2 and W plus 2.
All right. Thank you.
But so I think you are fine with the multiplication, but I can also give you division actually. Like AB over AB minus 3A divided by A over A minus 3. I always want to say multiplication, division, yeah, brother and sister, but calculation is a little bit different though.
Can we just flip it and just change the sign?
What do you mean? You need to clarify.
Like what's after the division, we can just flip it and make the problem for multiplication.
Okay, so let's switch then. Okay, so it becomes what then?
AB divided by AB minus 3A.
AB over AB minus 3A.
Okay.
Multiply A minus 3.
Times A minus 3 over A.
Oh, okay. Then we switch basically second factor, so up and down, right?
Yes.
Oh, that's great idea. Okay. Then now, can you factor this one?
Yeah, get the A common factor
Mhm.
and cancel it out with the denominator.
So then,
Minus 3.
so B minus 3 basically, right?
Mm-hmm.
Yeah.
Multiply A minus 3 over A. So any common factor between numerator and denominator.
For the first one, yeah, we can
A-
just cancel out A
A,
and A.
A minus 3.
A minus 3?
Yeah.
Where's A minus
No,
3?
sorry, I made a mistake.
It's
It's
A
just
squared.
it's just A.
I think A and A, right?
A and A.
Yeah.
That's it. Nothing
Yeah,
else.
that's will be.
It's
That's
clear
it.
to
Yeah,
everyone?
nothing else.
Yes.
Yeah.
If not, you better unmute you and then let me know. If it's clear, then you can still muting yourself.
Could you go over it again?
So basically, A times B over A B minus 3. So you understand these steps, right? Because of A and A, they're common factor. We factor by A, so become A times B minus 3. And the A minus 3 prime factor, A also prime factor, we stay as A minus 3 over A. Now, on numerator portion and denominator, A is common factor, so we cancel this out. Yes?
Yeah.
So therefore, answer becomes B times A minus 3 over A times B minus 3.
Yeah.
Okay. But be careful. This A, they are totally different factor. You can cancel them out. Okay. So now, so just one more questions. A square minus B square over A plus 3B divided by AB plus B square over 2A plus 6B. Okay.
First, we do the same thing
Yeah.
like we did in the previous one.
Mm-hmm. So it becomes
So if we transform the problem to multiplication.
yeah. So A square minus B square over A plus 3B, and then
2A plus 6B over AB plus B square.
good job. Okay. And what will be next step here then?
We factored A square negative B square to A plus B and A negative B.
Mm-hmm.
And the other one, we the same denominator on the second side, we factor with the 2 common factor. It's gonna be A plus 3B. And we factor the denominator with B.
Yeah.
It will be A plus B.
Okay. Good job. Okay. Now between numerator and denominator, can you find common factor?
We cancel out the A plus 3B between the
This
two.
and this.
Yeah.
And the A plus B.
Okay. A plus B.
And A plus B. Yeah. So
So will be
That's
left
it, right?
out with, yeah, gonna be left out with 2A negative 2B over B.
I mean 2 times A minus B over
Yeah.
E, basically. Any questions?
We must do it to the simplest.
What do you mean simplest?
So like we can't multiply the 2A negative 2B.
I mean, you can do that
Be
too.
like in
Yeah.
simplest way.
Yeah, that's fine too. But we prefer this expression more because this is the factoring form. This is the expanding form. So if I choose my preference, then this is a better answer to me. But nothing wrong with this one too. They're both are correct anyway.
No, because you said sometimes if you not simplify it to the end, you're gonna give us the triangle sign.
Oh, I see what you mean. Okay. So this case, as you see, there's no more common factor between 2 times A minus B and B. So there's nothing I can deduct. But now, if you can go a little further, this one, then you can also do 2A minus B minus 2, but I'm not going to require that. So
Okay.
as you stop here, then that's fine.
Okay.
Okay. But here, just in case, if you get maybe 2 times, I want to use different color. So what if you get 2 times A minus B over 4B? Then I can give you a deduction point unless you simplify. You know what I'm talking about?
Yes,
Yeah.
it will be
Yeah.
A negative B over 2B.
Yeah, then this becomes A minus B over 2B this case, because you can simplify basically. But this case, I don't see any other common factor. I can simplify, so that should be the answer.
Okay.
Okay. So basically, we covered today until 3.2. I think that's enough for today. And then because we are doing online session, so I couldn't move a little faster. So coming Monday, so unless I post, I mean, there's no such day we hold only exam anymore because everything's take off, right? So all class will be basically our discussion and the solving problem. So coming Monday, we will cover lesson 3.4 first, and then we go over to 3.3. Hopefully I can cover both sections together one day. Okay, so please watch the video 3.4 and then 3.3. Huh?
Okay, it will be at the same time, right?
Yeah, so we will cover both section 3.3 and 3.4, but I'm gonna start covering 3.4 first, and then go back to 3.3 later.
And we should watch the videos beforehand, before the lecture, right?
Yes, that will be much easier for you to follow this discussion. As you see, you know, this time, if today I give you a little bit more time, so I may keep the same way too, but if you watch my lecture video beforehand, then it gives you much better idea what is going on. And then another announcement is I'm holding office hour from 12 through this Zoom meeting room too. So go to Blackboard and then find out today ID session so you can join my office hour. Okay. Otherwise, have a great weekend.
You too.
Okay. All right then.
Okay.
Thanks for joining today, and then I will see you on Monday.
Okay, I have another question.
Yeah. Yeah.
Okay, for the office hour, we should make an appointment.
No. So I already post my online office hour ID number there. Same thing. You click then that link, then you can join the office hour automatically.
So you're not gonna be on campus, right?
Yeah. Okay, perfect. Okay, so now I'm gonna stop this meeting, and then if you need my help more, then I will see you during my office hour.
Okay. All right, thank you.
All right, have a good weekend. Bye.
Okay.
Thank you.
Okay, same to you.